Okay, so we're back again. We're gonna do part D this time. So before we figured out that the equivalence point is gonna be when you add 25 mils of NaOH. So we know that part D is gonna occur at equivalence point. So this is also another special case. So you have to do this a certain way. So at equivalence point, the volume of the vase is 25 mils and concentration of the base is 0.3. Volume of the acid is 25 mils and the concentration of the acid is also 0.3. Now we reverse the reaction. So I'm going to skip over the detailed section and kind of just tell you what you need to do to figure it out. So this is for those who just kind of want to get as many marks as you can. So if you remember, the original, very first initial equilibrium reaction was HF goes to F minus and H plus. In this case, you're taking the F minus and you're adding it with water, combining it with water, and you get a HF plus OH minus. Since you're making OH minuses, you're gonna need a Kb value because this is essentially a base because you're making OHs. So now, what's the initial concentration of F minus? Well, initial concentration of F minus is the exact same initial concentration for the acid, which was 7.5 times 10 to the negative 3 moles. So whatever the initial concentration of the original thing was, it's going to be for F minus now, the original acid. So okay. Now volume total is, well, 25 plus 25 because initially you had 25 and you added 25, so 50 mils. So the concentration of F minus is simply just this initial number of moles, sorry if I said concentration, the initial number of moles over the volume in liters, and you get the concentration of F minus is 0.15 moles per liter. That's it. And now we have a simple equilibrium equation. So you just have 0.15 as your initial, dash 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 for water, 0 and 0, x, 0.15 plus x and x. So now remember, kb is equal to x squared over 0.15 plus x. If you do the 100 rule, you should get, you can do it. kb is equal to x squared over 0.15. Well, okay, hold on. What is kb? We didn't, because they only gave us ka. Well, you know kb times ka is equal to kw. So kb is equal to kw over ka. So kb is equal to, well, kw is just constant, a number everyone should know. 1 times 10 to the negative 14, and k is 6.6 times 10 to the negative 4. That's supposed to be a 4. Okay, and then if you do the division, you get kb is equal to 1.51 times 10 to the negative 11. So now it's back here. So we know 1.51 times 10 to the negative 11 is kb. You times it by 0.15, and then you square root it. So x is equal to this. If you do the calculations correctly, you should get x is equal to 1.5 times 10 to the negative 6. So now you're getting POH because this is a concentration of OH. So negative log of that gives you 5.82. So pH is going to be 8.18. So in summary, this equivalence point question is very simple to do. All you need to know is that, okay, you need to know the volume of the thing that you're being added. You need to know that. You need to know this chemical equation. So remember, it's always going to be the opposite of the initial. And what I mean by that is, before you started with HF, going to H plus and F minus, in this case it's going to be F minus, and then you always add water, and then it's going to become HF and OH minus. The other important thing is you're going to use Kb here. The initial number of moles for this is going to be the same for the initial moles of the acid. So then it's the same number of moles, and then this is the important part. You need to divide by total volume, and then you get the concentration of F minus, and then it's just a simple ice table, and from there on you should be able to easily figure out the pH. And if you check the answer, I'm sure we got 8.18. Okay, good. And hopefully that